Okay everyone, this is part 2 and we'll be talking all about esters. Esters are a carboxylic acid derivative. That means that in order to form an ester, one needs to start with a carboxylic acid and react it with something. And this is the kind of compound that you get. It's called an ester. So here we have almost the carboxylic acid. Remember that this is what the carboxylic acid looks like, with an H on the oxygen, making it the terminal atom in your compound. Well, here in an ester, that's carboxylic acid. Here in an ester, that oxygen second bond is not a hydrogen, it's a carbon. So you have some sort of carbon chain here. Now, I've denoted here just an R for what's attached to the carboxylic acid portion of your molecule. And then this R prime denotes something different on here, the right side of the molecule, the one that is the carbon that's singly bond to the oxygen. That differentiation is going to be important here in a little bit. Okay, so these two parts of the compound, of the ester compound, are called different things. This part, this black group here, this is known as the acyl, A-C-Y-L is pronounced acyl, part of your compound. This is the part that's derived exactly from your carboxylic acid. R prime then is what we call the alkyl group. This is really just a substituent of our ester. So when we name these ester compounds, we are going to name the alkyl group R prime, the thing that has the single bond with the oxygen, as a substituent, as an alkyl substituent. In other words, we're going to use things like ethyl, not ethane, propyl, not propane, because we're going to name this part of our compound as a substituent. Now, this part of the compound is the acyl group. It is derived from the carboxylic acid, meaning that whatever carboxylic acid you start with, that is going to produce the acyl group in your compound. Okay, let's get some practice identifying the alkyl and the acyl groups. I personally find that it's easiest to first identify the alkyl group. So in order to do that, what you're going to do is find where the oxygen that has only single bonds is, and then identify where your carboxylic acid portion is. Everything that is on the other side of that is going to be your alkyl group. Now, it's important to note that when you're looking at this as a line angle formula, you're not overcounting your carbons. In this case, there are only 2 carbons. This line here denotes a bond between this carbon and this oxygen. That means there's not a carbon here at the end of this line. Okay, so you want to make extra careful that you are not overcounting your carbons anywhere here. And now if we have to find the acyl group, that's everything other than the alkyl group. So that's not super hard. There it is. Let's do some more of these. Okay, find your alkyl group first. Find your oxygen that's singly bonded to 2 different carbons. That's this oxygen right here. Find your carboxyl carbon, or your carbonyl carbon, I should say. And then, because that's on the right, this time your alkyl group is here on the left. Now practice numbering this. We have 3 carbons, and then this is a substituent here. So if we had to name this, as a substituent, we call this 2-methyl propyl. And that's what this is, that whole thing in the green box is called. 2-methyl propyl. Not 2-methyl propane, because we have to name this here as a substituent. That's why the YL. That's why you have the YL. Alrighty then, your acyl group is this portion right here. We'll talk about naming that in just a bit. We have one more. Oh. Okay, well we can move on to naming. We'll get plenty of practice identifying those two groups as we move along. Okay, so what we're going to do is we're going to first name the alkyl group. And that's going to be the first part of our name. So we're going to name that just exactly like I named this group here. Then the second step is what's a little bit complicated. We have to name that whole acyl group like a carboxylic acid. We're going to go through all of the steps of naming it just like a carboxylic acid. Use the oic acid if it's acyclic, and if it's cyclic, use carboxylic acid at the end. Then, whatever our ending is, we're going to change ic acid to 8. So at the end of your compounds, you're either going to have O8 or carboxylate. This is for cyclic. This is for acyclic. Okay, let's do some examples. Okay, here we have a compound, and I've already gone through and identified the acyl and the alkyl groups. Let's name that alkyl group. Here we have a 3. 3 is propyl. Now let's name the acyl group like a carboxylic acid here. 1, 2, 3, 4. Now you're not doing anything silly like watching these movies out of order, are you? Because if you are, go back and watch part 1. I never thought that you might be doing that, but in case you are, go back and watch part 1 first. Okay, so here we have 4 is butane, so we have butanoic acid. Okay, now go back and read the directions here once. This is the first part of the name. That alkyl group is the first part of the name. So then, when we change this ic acid to 8, that's going to be the end part of the name. Okay, so here we have butanoic acid, so that we're going to change to butanoate. So then putting propyl at the first part of our name, and that is a separate word. So you should have 2 words here, propyl butanoate. And that's how you name an ester. Don't worry, I have plenty more examples for you. This is where I was just working through this. That was the last example. Okay, find that alkyl group. Find it. Here we are. 4 is butyl. Obviously, naming the alkyl is the easier of the 2 things that you should do. That's why we always do that first. Go with the easy stuff first. Alright, acyl. How do you name this as a carboxylic acid? If you can't think about it right off the top of your head, you might want to go back and watch a little bit of part 1. This is cyclohexane carboxylic acid. Do you need the 1 in front of cyclohexane? No, because we are always assuming that that's going to be on carbon 1. cyclohexane carboxylic acid. And add that butyl. So if we do that and add 8 at the end, we should get butyl, second word, cyclohexane carboxylate. Butyl cyclohexane carboxylate. And your carboxylate this is all one word here. Cyclohexane carboxylate. I can't remember if in part 1 I was showing you to do that as one word, but you should put that carboxylic acid. Carboxylate should be part of the parent cycloalkane. Okay, this is one from your homework. Find your alkyl group. Name it. Find your acyl group. Name it like a carboxylic acid. Put them together. Drop acid. Add 8. Oh. Butanoate is what you should get. Ethyl butanoate. And that is number 18, page 3 of your homework. Okay, let's talk about a few of the interesting esters. Usually the really small esters, the ones that have small alkyl and acyl groups, they're very fragrant. And when you manufacture them, they produce perfume-like odors. A lot of times in the perfume industry, esters are produced because they can be used, they have a long shelf life. And as you know, those of you who are women might know this better than the men, depending on if you guys use aftershave or not. But perfume doesn't have an infinite shelf life. So if you buy even an expensive perfume and leave it out on your dresser for long periods of time, especially exposed to light or direct sunlight, those compounds will eventually break down over time, and that's what gives you the old lady perfume kind of smell, because your esters in the compound are actually degrading. But they last a pretty long time as far as fragrant aromas go, and that's what makes them useful in a perfume. Let's look at a few of the interesting esters. Okay, here are 3 that are particularly interesting. Methyl salicylate is this compound right here, and here is the ester functional group right here coming off of your benzene. This is the oil of wintergreen. So when we synthesize this in the lab, it smells like wintergreen lifesavers. Here is ethyl butyrate. This smells like the pineapple. This is the odor of pineapple. And here is odor of banana. These are the compounds that give these items their smell. Vitamin C is water-soluble vitamin containing a 5-membered lactone. You don't have to worry about that. Humans do not have the necessary enzymes to make it. And that's why vitamin C is an essential part of your diet. When you don't have enough vitamin C, you get very, very sick, because you can't produce it in the body. This compound is ginkgo extract, and hopefully if we can see it. Ooh. This is a immunosuppressant drug that is used to treat patients. And as you can see, that has many, many functional groups. Remember what I said about drugs being useful in the body because they have so many functional groups? There are lots of reaction sites. If you look, you can find the ester right here. That's all we have for esters.